Welcome to The Explainer. Today, we're going to talk about a tool that is seriously changing the game for data science, Azure ML Designer. It's a way to build, test, and even deploy really powerful machine learning models, all visually, without having to write a single line of code.
Okay, so let's just jump right into the big question at the heart of all this. When it comes to building a machine learning model, do you really have to be an expert coder?
You know, for the longest time, the answer was a huge yes. It was all about Python, R, complex scripts. You kind of had to live and breathe code. But that's not the case anymore. Powerful new tools are completely rewriting the rules. And this right here, this slide lays it out perfectly. On the left, you've got the old school code-first way using what's called an SDK. That's where you have total control, line by line. But on the right, you have the visual-first approach of the designer, where you're literally just connecting boxes together to build your logic. So, the easiest way to think about the Azure ML Designer is like digital Legos for data science. Seriously, you have a block for your data, a block for cleaning it, a block for your algorithm, and you just snap them together on a canvas to create a complete workflow, or what we call a pipeline.
Okay, so now we know we have these two powerful options, the visual designer and the code-based SDK. The big question is, how do you pick the right tool for the job?
And the thing is, it's not about which one's better in some absolute sense. The real question is, which one is better for you and what you're trying to do? It really comes down to your skills, how complex your project is, and what you're trying to achieve in the end.
And this table just nails the breakdown. Basically, the designer is your go-to if you prefer a visual interface, especially for standard models, or if you need to quickly prototype something. On the flip side, the SDK is where you want to be for the really heavy-duty stuff, like super complex deep learning, setting up sophisticated automated workflows, CI/CD pipelines, or when your entire model is custom-built.
All right, enough talk, let's actually see how this works. We're going to walk through the fundamental steps of building your very first model, all on that visual canvas.
And it all boils down to this classic four-step recipe that you'll see in pretty much any machine learning project. First, you split your data, so you have some for training and some for testing. Second, you train your model with the training data. Third, you score it, which is just a fancy way of saying you make predictions. And finally, fourth, you evaluate it to see how well you did.
But here's where it gets really cool. Beyond just the basics, the designer comes packed with these, let's call them power modules, that help you solve really common but tricky data science problems right out of the box. Let's check out 3 of them.
Okay, so here's a classic problem. What do you do when you're trying to predict something that almost never happens? Think about credit card fraud, or maybe a specific type of machine failure. Most of your data is going to be normal, and that can make your model really biased. The answer is this amazing little module called Smote. Now, don't worry about the full name. Here's the magic behind it. It looks at your rare examples and creates new, synthetic ones that are super similar. It intelligently balances your data set so the model can actually learn what to look for. And you just drop it in your pipeline right before training.
All right, next challenge. Your model works, it's making predictions, but you have no clue why. Which parts of the data are actually important? Is it a customer's age, their location? And trust me, you're going to get asked that question.
And for that, you bring in the detective, the permutation feature importance module. This thing is so clever. You connect it to your trained model and it starts messing with your data on purpose. It shuffles the values in one column and sees how much that messes up the accuracy. The bigger the drop in performance, the more important that feature was. It's how you can confidently explain why your model works.
Okay, last one. We've all been there, right? You get a great score and you think, wow, this is amazing. But then this little voice in your head says, was that just luck? Maybe you just got a really lucky split of your training and testing data.
Well, that's exactly what the Cross-Validate Model module is for. Instead of just one split, it's like a stress test. It automatically splits your data into multiple sections or folds, and then it trains and tests the model over and over again, each time using a different piece for testing. This gives you a way more reliable score, and you don't even need that first split data step.
Okay, so you've built an awesome model. It's validated, but that's only half the battle, right? The real magic happens when you actually put it to work in the real world. Let's see how the designer helps you get it out there.
And the designer gives you 2 main ways to do that. You can go real-time, which gives you a web service that an app can call to get an instant prediction, like right now, or you can go batch, which is built for processing huge chunks of data all at once, maybe on a schedule, like running predictions on your entire customer database every night.
All right, we have covered a ton of ground. So just to make sure all these ideas are locked in, Let's do a quick-fire round with a few common scenarios you might run into. First one, you're trying to predict a rare event, and your model is totally biased. It almost always predicts the common outcome. What do?
You got it. You bring in SMOTE. And the key thing to remember is when you use it. It has to come before you train the model to fix that imbalance, before the algorithm even sees the data.
Okay, next one. You've built a model that predicts a number, maybe a price for a house. Now you need the report card. Where do you find those key stats, like R-squared or root mean squared error, that tell you how good the model is?
And the trick here is knowing that two different modules are doing two different jobs. The score model, that's your prediction factory. It just churns out the numbers. But the evaluate model, that's your quality control department. It takes those predictions and grades them against the real answers.
Okay, last question. Let's say you want to have a bake-off. You've got two different models, maybe a simple linear one and a more complicated decision tree. How do you set up a fair head-to-head competition to see which one's better?
And the solution here is just so elegant. The Evaluate Model module actually has two little slots on the top. You just drag a line from each of your scored models into that one module, and boom, you get a beautiful side-by-side report comparing both of them on all the key metrics.
You know, when you make machine learning this visual, this accessible, you're really changing who gets to participate. It's not just about who's the best coder anymore. It's about who has interesting questions and important problems to solve. So that leaves just one last question. What problem will you go solve first?